Hi, my name is Guang, 12 years old. For this lesson, we'll be continuing on with the techniques and applications for definite integration. For this lesson, we'll be continuing on with the example from the previous lesson where we had the same example, which is double integration dx squared y squared dx dy, and the capital D is bounded by xy is equals to 1, xy is equals to 2, y is equals to x, and y is equal to 4x in the first quadrant. So over here, supposingly you have the first and the third quadrant, but over here we only need the first quadrant, so we only have the top right part. So for the previous lesson, we have already gotten the result for this example already. Well, for this lesson, we'll simply be just using a different method. But when I say different method, it's in the sense that it is for the last lesson we used Cartesian coordinates. For this lesson, we're going to use polar coordinates, not the dx dy part. So over here, what we have is that, so x, what is x equals to? X is equals to r cosine theta. And then y, it is equals to r sine theta. So what we have here is that we'll have bracket r cosine theta square, r sine theta square, r d theta. Okay? Alright. So for this part, what we're going to get here is that, so the integration, and so we'll be doing the radius first because it will be simpler and all. So it will be from the AD arc to the BC arc, right? Which is basically from xy equals to 1 to xy equals to 2. So over here, x and y, we sub the r cosine and r sine theta, which we are going to get r square cosine theta sine theta equals to 1. So what we're going to have, we'll also have r square cosine theta sine theta equals to 2. So over here we're going to have r squared is equals to, so in order to find the radius for both of these and have our boundary, so we'll have to find r for both of these functions. So r over here in the xy equals to 1 is 1, so r squared is 1 over cosine theta sine theta, and r will be equals to 1 over square root cosine theta sine theta. Well, for the xy equals to 2, r squared is going to be equals to 2 over cosine theta sine theta sine theta, and r you'll get square root 2 square root cosine theta sine theta. Okay, alright. Now that we have gotten this, we have gotten our boundary, which is from this to this. Okay, basically from 1 over square root cosine theta sine theta to square root 2 over square root cosine theta sine theta. Now that we have gotten for our r, what we're going to have now is for our theta. So for our theta, what we have is from CD to AB, right? So over here, what we have for CD is y equals to x, which is basically r cosine theta is equals to r sine theta So over here, cosine theta over sine theta will become tangent theta, while the r's will get simplified, right? So here you have tangent theta is equals to 1. But over here what we're trying to find is CD theta. So theta for y is equal to x will be tangent, inverse tangent 1. Then what about for y is equal to 4x? So for y is equal to 4x, it will be r cosine theta equals to 4r sine theta. And we'll have tangent theta is equals to 4, so theta will be equals to inverse tangent 4. Okay, alright, so our boundary will be from inverse tangent 1 to inverse tangent 4, and we can clearly tell that inverse tangent 1 is pi over 4. Okay, so basically we'll be going from pi over 4 to inverse tangent 4. Well, inverse tangent 4 we cannot solve because so we'll be going from now that we have figured out for the boundary for r, we also have to figure out the boundary for theta. So in order to find it, instead it will be from DC to AB. Okay, so which will be from y equals to x to y equals to 4x. So what we're going to have over here is, so y equals to x will be r sine theta equals to r cosine theta. So over here you can divide, so you can move this here, whereas the r will simplify, and the sine over cosine will become tangent theta, and it will be equals to 1. But since we are here to find theta, so theta will be equals to inverse tangent 1, whereas inverse tangent and 1 is basically pi over 4. And now that we have figured this out, we will also have the r sine theta equals to r 4r cosine theta, which is the y equal to 4x. And once again, the r's simplified, and we'll have a tangent over here. So it just said it will be tangent theta is equal to 4, and theta will be inverse tangent 4. And since we cannot, and since over here we cannot solve for inverse tangent 4, we're just going to straight out put it in the boundary, which is going to be from pi over 4 to inverse tangent 4. Okay, so give me a sec. There. And now that we have gotten this part, we can continue on and put the r's together, and you'll get cosine square theta times sine square theta, and then here we'll have r to the power of 5. So r to the power of 5, this time will still be integration. So integration will be from 1 over square root cosine theta sine theta, and then square root 2 over square root cosine theta sine theta. And what we're going to have here is dr d theta. Okay, alright, so now that we have gotten this part, what we're going to get next is we will integrate this, and we'll get And here we'll have 1 over 6 r to the power of 6, and then we'll have 1 over square root cosine theta sine theta, and square root 2 over square root cosine theta sine theta. And we'll have the theta over here. Now that we have gotten this, we can sub in the boundaries and we'll get. So apparently over here, if you realize for this power we're having is so first for this part we'll have square root 2 over square root cosine theta sine theta to the power of 6, which will end up being so square root 2 to the power of 6 is basically 2 to the power of 3, which is 8, and cosine theta sine theta, for this part it will become the square root removed here, it will be to the power of 3 cosine cube theta sine cube theta, and then minus of 1 over cosine cube theta sine cube theta, and then d theta. And now that we have gotten this, what we're going to get next, over here minus, you get 7 over 6, and you have pi over 4, and then tangent, inverse tangent 4, and then you have cosine square theta sine square theta, and here it will be over cosine cube theta sine cube theta d theta. Now that we have gotten for this part, we can simplify the cosine square theta and sine square theta, and you'll get we can now over here take out half from here and place it over here, and you might wonder why would I do that. Well, as you can see for this part, 2 cosine theta sine theta, it looks very familiar. So it will be sine 2 theta. So sine 2 theta over here, you basically just use the double angle formula, and then for this part you can times the sine 2 theta on both numerator and denominator. So for this part, the sine 2 will become sine 2 theta square, and for this we can put the sine 2 theta inside this part, which will have a d. So here we will not just get the d cosine 2 theta, well over here we'll also have a negative end. So it will become, so for this when you integrate sine, you get negative, and then 2 theta, the 2 you can put it outside, which will get seven over 6 again. Okay, so for this part, what we're going to have for this, for the denominator is so here for this is that, so sine square theta. So what could it possibly be? So sine square theta is basically 1 minus like this, 1 minus cosine square 2 theta. Well, you may be wondering, what's the use of this? This you have square and all those. Well, you'll see that you can actually use partial fractions over here, and you'll get, so later I'll have to change the coefficient in front. Okay, so over here, okay, so what is, so if you realize over here 1 minus cosine square 2 theta. So over here what I use basically the sine square theta plus cosine square theta is equals to 1, okay. So over here you realize that 1 is basically 1 squared. So over here is basically a square minus b squared, which will be a minus b times a plus b. Now that we have gotten this part, we can partial fractions, and you get, I'm going to continue this, I'm going to write this later. So what we're going to have here is that you can separate it. And over here you have, so if you realize if you put these two together, what you're going to get is you're going to get the fact if you put these two common denominator, yes, the denominator will be 1 minus cosine square 2 theta, but the numerator over here you have 1 plus cosine 2 theta plus 1 minus cosine 2 theta. So although the cosines will cancel each other out, but for the 1 you'll have 2 above. So here, in order to partial fraction for this part, you need another half, okay? So now that we have gotten this part, we're going to get so here we'll have another negative for this part because first you're going to have d1 minus cosine 2 theta, so you need a negative over here. And then we'll add so over here, although this part is add, but we have the negative in front, so it becomes minus. And here we have d, and we wouldn't have another negative because it's plus 1 plus cosine 2 theta and 1 plus cosine 2 theta. Now that we have gotten this part, we can integrate already. So what is dx over x? So dx over x is ln x, right? So over here you have ln 7 over 12 ln 1 minus cosine 2 theta to tangent inverse tangent 4, then you minus 7 over 12 and this is what you get. So apparently you can put these two together because that ln x minus ln y is basically ln x over y. So you're going to get 7 over 12 ln, and just so you know, because the boundaries are the same, so that's why we can also put them together. So what you're going to have is, so you can substitute the one minus, so before that it's going to be like this, okay? And so for this part, what you're going to get here is that, so first you have the inverse tangent, and so inverse tangent is basically the sine over cosine. So apparently over here so I'm going to erase it, just take a quick look. Now over here, before we sub in the boundaries, we can so what is cosine 2 theta equals to? So cosine 2 theta over here being cosine square theta minus sine square theta, it is basically like this, okay? And now that we have gotten this, we can substitute this. No, we use double angle formula for this part, whereas we're going to get 2 sine square theta. Well, the 1 minus 1 will cancel each other out, and the negative and negative will become positive. Well, for denominator here, well, the 1 and the negative 1 will cancel each other out, and we'll have 2 cosine square theta So now that we have gotten this, what we're going to have now is that, so for this, the 2 and the 2 will cancel each other out, and you'll have tangent square theta. So over here for this part, we can substitute the boundary inside, and what we'll get will be, so for the first part we'll have, so over here tangent inverse tangent, they will cancel each other out, and here we'll have 4, right? So for this part we have 4, but over here, as you can see, for this part it will be 4 square, because there's a square here, which will, whereas the square over here, you can move it to the outside the lawn, whereas it's going to simplify with the 12 and become a 6. Well, for this part, what we're going to have, as I told you, ln x minus ln y is basically ln x over y. So basically you can put this in, and since tangent pi over 4 is 1, so technically speaking, this is basically 4 over 1. So now that we have gotten this part, we will have, so it's basically, and what we're going to here is that 4 is basically 2 square, right? And once again, the square you can move out, and you'll be 7 over 3 ln 2. And that is the answer that we'll get. And if you compare this answer to the previous answer for the same question, and it is the same. And let me just give you a quick look of what the method for polar coordinates is. So first what we mainly did was to just find the boundary here, which is for just the AD to BC, and then we also had the degrees from DC to AB, and then after that over here for this part integrate, then after the integration what we mainly had was just a double angle formula, which we had the 2 cosine theta sine theta equals to sine 2 theta, and then here we after that we times sine square 2 theta for both numerator and denominator, and then we use the double angle formula again, whereas sine square theta plus cosine square theta is equal to 1, and we gotten this, and we use the a square minus b square, and then after that we mainly just integrated, and then we got the ln, and once again we use the double angle formula. Okay, so for this lesson we mainly use the double angle formula and the sine square theta plus cosine square theta equals to 1 and the partial fractions. So that'll be all for this lesson. Take a quick look. Last but not least, thank you for your watching.